Hello and welcome to another Talking Maths video. Today I'll be doing a Christmas quiz with questions based on topics that we've done in the past, just to see how well we've understood this for the rest of 2019, which is almost over. Okay, so looking at the first question, this is a Pythagoras theorem question, where Bob has 40 metres of Christmas lights and he wants to hang them from a point on the ground 7.5 metres away and perpendicular to his house to a point on his house 8.7 metres above. So we've got a triangle here with a right angle. How much lighting has he got left? So we're going to have to work out the length of the lighting he's strung, and take 14, take away that would be our answer, the remainder. So if I just have our triangle here, I'm going to need to do 7.5 squared. That is equal to 56.25. .7 squared. $75.69. Okay, so if we just add them together, I get 131.945. Go to square root that, I will get my answer 11.486. So if we do 14 minus my answer, I will get my final answer as 2.51 meters. Okay, so we'll go to the second question. Fill in the missing length and angles on the triangle. Okay, so here we're going to have to do a sine and cosine rule. So I'm going to work out A first using the sine rule. So to do that, I'm going to put sine of A over the opposite angle, which is, or side, sorry, which is 9, is equal to 8 over sine of, what's opposite 8? Sine 60. And using that, I'm just going to simply say that A would be 76.976 degrees, okay? Okay, so I know that one, so I'm going to tick that off. Now I know this angle, so I can work out my B angle. Just do 180 to take the sum of them two. That will get us 43.023 degrees, okay? And I want to work out this side, C, and I know that side, and this angle, so I can use the cosine rule. I'm not going to write down the whole cosine rule, I don't have enough space, but if I were to work out the cosine rule, I'd get that C is equal to 6.302 meters, okay? So if you want to see how to do the cosine rule, I've got a video on that later. So I've got all the answers for them too. Moving on to question 3. It's find the vertex of the graph of y equals x squared plus 8x plus 7. So we're going to have to complete the square to get that y is equal to, then x, we need half the middle width plus 4 all squared. We have a plus 7 on the end, but we need to take away this squared, so that would be minus 16. Simplify that, we get y is equal to x plus 4 squared, and this would be minus 9, I believe. Okay, yeah. So we can work out the coordinates of the turning point would be this as our y, so minus 9, and the opposite of plus 4, which is minus 4, by x. Nice, simple for that. So here, I've got a Christmassy question. Santa's sack acts as a function, f of x, when it contains presents. The present with the function g of x is put inside. Find its new function when f of x is equal to x plus 1, x minus 1 all squared plus 2x, and g of x is equal to minus 2x. So we're going to have to do f of g of x, a composite function. Okay? So, right, I'm going to substitute g of x where there's an x in f of x. So I'm going to get, instead of x minus 1, I'm going to get minus 2x minus 1 all squared plus 2x. So I'm going to expand this bracket, so I'm going to square both these terms and times them together and double that, so I get so I get 4x squared plus 1. Minus 1 times minus 2, we get plus 2x plus 4x because we're doubling it, and add this 2x at the end, we get plus 6x. So there we go. So all we have to say is it is 4x squared plus 6x plus 1. Alright, there we go. And here, oops, Santa sat on the present and reduced its value to 0. Using your derived function, solve for x. So as you notice, we've got a quadratic thing, and we can say this is now equal to 0. Plus 6x plus 1 is equal to 0. Alright, so it's going to factorize, hopefully. I'm going to put this into formula actually and get minus b, so minus 6, plus or minus square root of 36 minus, that would be 4ac, so 4 times 4 times 1 all over 8. Okay, so we get 4 times 4 times 1, that is 16. 36 minus 16 would be 20. So we're going to get minus 6 plus or minus root 20 all over 8. And I'm actually just going to leave it as my answer, so we can say that x is minus 6 plus root 20 over 8, or minus 6 take root 20 over 8. Okay, there we go. Final question, find the nth term of the following sequence. Okay, so this is a fractional sequence, which means we're going to have two different sequences, one on the top, one for the bottom. They don't have to go the same, you don't have to work these out as decimals. So for this one, I'm going to find the difference at the top, or 3 of them. So this would be 6, this would be 10, and this would be 14, and these go up by 4 each time. So if I half that and put that in front of n squared, I have that term. And if I were to work out 2n squared, I'd get 2, 8 and 18 for the first, second, and third terms. So I know it just is 2n squared on top of the fraction. Now for the bottom ones, be a little tricky to work out derive, but instantly from our video on these, we can tell that these are factorials of terms. So this would be n factorial, because we get 1, 2, 6, 24, 120. Alright, that could be a valid sequence. So all we can write as our answer is 2n squared over n factorial. And we're done. So thanks for watching this video. I really hope you enjoyed it, and I hope you have a very Merry Christmas from Hendog Maths.